Well, let's see if we can find a reflection of a line on the coordinate plane. I'm going to start with this blue line, my given line, with a y-intercept of 2 and a slope of 3. And we'll call that the blue line our pre-image, exercise number 27 here in your textbook. So, well, I'm going to reflect it over this line. This is my axis of reflection. I know I can visualize it being like that, but let's see if we can figure this out. Where does that line really go? How do you draw it? Well, I know this distance. I'm going to take the distance here, perpendicular distance from the line of reflection to the y-intercept. Well, that would reflect down here to -4. Well, we could go point by point on this pre-image or blue line, but I think we'll just use that one. That's as much as we need because, well, right now we know the intercept of the image. Now, I know I've got a slope up 3/1. See, this blue line crosses through or contains this point. So this point is also in the reflection. This point is in the reflection. I only need 2 points to determine a unique line, ray, or segment. Up 3/1, down 3/1. Again, up 3/1, down 3/1. So the slopes are, of course, as you might have guessed, opposites. The opposite of slope of 3 is -3. I've got a slope, I've got an intercept, I've got an equation. And just to show you again, there's your line right there. Well, let's take this graph, a parabola, and well, first draw a picture of it. And we're going to reflect it over the horizontal or x-axis. Now, it might help if we just take some integral points along that curve. And you know that we could find those reflections just like we did in the last exercise. And those would be up there. And then the graph would be over here. That's the reflected graph. What's the equation? Well, we've got the opposite coefficient, and of course we have the opposite vertex.